Well, in this geology major this morning, I'm the first of three speakers. I'm going to be as brief as I can be on what is a huge topic that we could spend a whole week talking about, and that is the Precambrian rocks, because they're quite a significant component of the Earth's crust. But let's dive into this pretty quickly. As the name implies, these rocks formed during before the Cambrian, before the major fossil sedimentary bearing rocks that were deposited during the flood. The Precambrian strata consists of granites and metamorphic rocks in massives, that is in complexes. They're overlain by thick sequences of sedimentary and volcanic rocks, or there are belts of sedimentary and volcanic rocks adjacent to and between these massives. Let me give you an example. Here's where we've got these Precambrian foundational cores of the continents. They're called cratons, but they are indeed the exposed foundational rocks of the continents. And you can see that there are areas exposed at the Earth's surface today of these rocks. There's no remnants of flood rocks in some of these areas. They're exposed, these foundational rocks. If we go to, there's two areas that are well known and well studied, the Pilbara area in Australia and the Barberton mountain land of South Africa have got some of the oldest exposed sequences. Another area is in Greenland, where there's a lot of rocks that are being studied from the earliest part of the record. If we go here to the Pilbara Creighton, this is a satellite photograph on the left, and here's the area that is involved. You can see these granite massives, these domes of granite, and in between are these linear belts adjacent to them. These are made up of sediments and sedimentary and volcanic rocks, and they're quite thick. And these belts are called greenstone belts for a reason that I'll tell you in a moment. Invariably, there is an erosion surface called an unconformity on top of all the Precambrian strata, marking where the floodwaters eroded their way across and over the Precambrian strata to deposit their load of sediments. And Dr. Steve Austin will talk a little bit more about that, the pre-flood flood boundary, but we'll touch on it here. This erosion surface is very visible in the Grand Canyon, where it's called the Great Unconformity. And I'll show you that, but he'll elaborate more on it in a moment. Here's the Grand Canyon. As we say, it's a wonderful place to study, a mecca for geologists, simply because you've got exposed to view an incredible slice of rock units that represent the full spectrum of Earth history. And so in the Grand Canyon, we have this great unconformity here at the base of the virtually horizontal stack of pancakes with the fossils in it making up the flood rocks. And below that, we have the Precambrian strata here, typically well exposed in the inner gorge of Grand Canyon. Well, here it is from the Grand Canyon village in the central area. Again, walk you through it. These are the flat-lying pancakes layers from early in the flood. Below that, the Great Unconformity, which is here in this photo here, and again over here. You've got Precambrian sedimentary layers sitting on top of this crystalline basement. Again, we can see this in the western Grand Canyon. This is the narrowest part of the canyon, Granite Narrows. Here's the Precambrian crystalline basement rocks. You've got Precambrian sedimentary rocks on top. You've got the Great Unconformity here, and then you've got the flood layers. Here's the first exposure as you go downriver of the Great Unconformity. Here's the first rocks of the flood. Here are these upper Precambrian sedimentary layers, and they are at an angle. They're being tilted, eroded off, and then the flood layers on top. Here's a closer view of that Great Unconformity. At this boundary, in conventional terms, there's regarded to be a stepping through 500 million years or 500 million years of missing time and materials. Here's another exposure. As you go downstream, we can see the Great Unconformity here with the Tapete sandstone, the first of the flood layers. And we can see that there's an angle. These are the Cardenas basalt, and here's the Docks Formation, 7,000 feet of siltstones and mudstones, and they're tilted. Here again is the Great Unconformity, the first of the flood layers, and here the first of the flood layers sits directly on the Precambrian crystalline basement. That's at River Mile 120, Blacktail Canyon, and then further downstream in the inner gorge, you've got here's the crystalline basement, and again the Great Unconformity and the flood rocks sitting on top. And again, another illustration here. You can see the schists, the metamorphics, the granites intruding into it, and you can see the Great Unconformity and the flood layers. Now, this immediately raises questions about the origin of these Precambrian rocks. We're all comfortable with talking about the flood layers up here with the fossils in, but our opponents say, well, look at these rocks down here. Don't they represent a long history prior to the flood, a long history for the Earth? And one of the articles that's been posted criticising the Is Genesis History movie, what are you going to do with a mile sequence of sedimentary layers before the flood? And that's a valid question that we're going to do. What do these Precambrian rocks mean, and what do they represent? So beneath the Great Unconformity in the Grand Canyon is a 2-mile thick sequence of tilted sedimentary layers and some basalt lava flows, and underneath those is the crystalline basement composed of metamorphic rocks and granites. So if all of these rocks formed before the flood, how do we explain how such a huge thickness of strata formed in the pre-flood era in so little time? I mean, after all, if you're going on a strict chronology from creation to the flood, you're talking about 1650, 1700 years, and then you've got the 6 days of the creation week when the Earth was formed on day 1. So it's a very little bit of time to explain a huge volume of rocks. How do we deal with this? Well, to answer this question, we need to ask ourselves, to answer this dilemma, we have to ask, what would a created rock look like? What would a created rock look like? We go to the outcome of two of Jesus' miracles to get an answer. The marriage feast of Cana in John 2, 1-11, Jesus instantly created wine out of water, yet the master of the feast couldn't tell the difference between the wine that he was tasting from that Jesus had created and the wine he'd been drinking earlier that had formed by, quote, natural processes. Except he commented that the created wine was better. And both were wine. Both looked as though they'd been grown on, come from grapes grown on vines crushed. In other words, the wine that Jesus created looked as though, from a human reasoning perspective, it had a history. And when Jesus created more bread and fish from that little boy's lunch of 5 loaves and 2 fishes, the people, the 5,000 men plus women and children who were eating lunch that day, didn't realise that they were eating bread that had been instantly created. In their minds, it was bread that had come from wheat that was crushed and, made into dough and baked in an oven, except Jesus didn't have an oven out there by the Sea of Galilee. And so that tells us, the bread and fish looked and tasted exactly the same as the boy's original lunch. So that tells you that a created rock would look exactly the same as a rock that was formed by subsequent geologic processes. And that's a very important concept to get our minds around. Our natural tendency and our natural effort to reason and explain wants to put geological processes that take a long time somehow into the equation, when Jesus demonstrated that he could do things instantly. We shouldn't be surprised, because on day 5 in the creation, day 3 in the creation week, God created fruit trees already bearing fruit, we're told. Why? Well, Adam and Eve would go hungry 3 days later if they had to wait for the trees to grow from seeds and eventually fruit. So, God created a fully formed, fully functioning, mature universe. So why wouldn't he create rocks fully formed and mature, ready to be land and seafloor. At the marriage feast of Cana, the master of the feast made the mistake of viewing the evidence that is the created wine in terms of present-day processes. He wrongly interpreted the evidence in front of him. He spoke to the bridegroom. He didn't speak to the servants. The servants were the eyewitnesses. He made the mistake of using his human reasoning rather than speaking to the eyewitnesses, because the servants had seen the miracle and they would have told him, that man over there told us to put water into these pots and he turned it into wine. He would have got the correct answer if he'd talked to the correct people, the eyewitnesses. And we can easily make the same mistake by looking at these rocks, just like sadly some of our colleagues do, who claim to be Christians. They look at these Precambrian rocks and say, how are you going to explain it? Well, I don't have to explain it because God tells me that he created the first rocks. And all I have to do is figure out which of those rocks were the first created rocks and what happened from then on. And so that's the challenge. You know, we go to Genesis, to the eyewitness testimony, and let's figure out, you know, Genesis isn't an exhausting account, but it does give us clues. We can infer from what the text says, and then we can test that, our inferences, our models, against the evidence that we see. And let's start to do that. You know, when I look at, on the left, a Precambrian metamorphic schist, that's in plain polarised light, whereas the one is and the right is under cross polars, there really doesn't look to be a big difference between a Precambrian and a post-Cambrian metamorphic schist or a granite. A Precambrian granite could look exactly the same as a post-Cambrian granite. But there are rocks that are unique to the Precambrian, and I'll mention a few of these. Kurt introduced this earlier in the week. There are several rock types that are unique to the Precambrian rock record, particularly in the Archean, which is the lowermost part of the Precambrian rock record. There are the tonalite, trogomite, granodiorite rocks. These are granitic rocks we'll come to in a moment. There are rocks called komatiites, and they're the banded iron formations, or BIFs for short. What are tonalites, trogomites and granodiorites? They're granitic rocks with plagioclase, felspar, very much in greater abundance than potassium felspar. Under laboratory conditions, these sorts of granitic rocks require lower pressures, that is shallower depths in the earth to form, and higher temperatures to form their magmas than other granitic rocks. They're predominant in these early Precambrian foundational core complexes, and they have a different chemistry to similar granitic rocks that are later in the record. So there are some differences. So here's these Precambrian tonalites, trogomites and granodiorites, and over here where they plot in this potassium, sodium, calcium triangle. But the post-Archean or early Precambrian granitoid rocks have a higher calcium and potassium content. So there are rocks that are unique to the Precambrian. The komatiites particularly, these are rocks that have, we can see these crystals here. These are needles of olivine, which is magnesium iron silicate. It's the major component of the Earth's mantle. And so this texture is called a spinifex texture. It's named after a grass in the outback of Australia called spinifex, which has long spindly needles, and that's reflected in these long spindly olivine crystals. Has a high magnesium content, greater than 25% than regular basalts. Under laboratory conditions, the magma to produce these rocks would require them to erupt as lavas at 1600 degrees C compared to 1250 degrees for a regular basalt. So much higher temperature under laboratory conditions. I'm not saying they erupted under those temperatures. All I'm saying is that's under natural processes, that's what would require. And they're common in the early Precambrian, And they don't occur very much at all when we get to the flood. We have regular basalts. There's only one or two places on the Earth today where we still have some small representations of these komatiites, similar to komatiites, that relate to the flood record. And these komatiites occur as lava flows in the sedimentary rocks in these linear belts between the granite massifs. And it's the olivine, which is green, which makes the lava rocks look greenish. That is the reason why these belts are called greenstone belts, because of these komatiite lavas. And you can see here in this stratigraphic section, Barberton Mountainland, Pilbara in Australia, you can see they dominate in these greenstone belts. The other rock that is unique to the Precambrian is these banded iron formations, typically thinly bedded or laminated chemical sediments. Why? Well, we'll come to that in a moment. They're typically greater than 15% iron. The iron 3+ to a total iron ratios are very high due to the presence of abundant magnetite. Magnetite is the reduced form of iron oxide. The oxidized form of iron oxide is cherry red hematite. Magnetite is black. It's the magnetic iron oxide that is a common component in a minor constituent in basalts. And what makes us think that these iron-rich bands, which are typically the iron-rich bands can be up to 65 to 70% iron oxide. And as Kurt mentioned, they are the major source of iron ore in the world for steel production. And, but they alternate, they're banded, the darker bands here are the iron-rich sediments, the lighter bands are chert. And chert is silica, cryptocrystalline quartz. It's precipitated from hot water, typically, and it's a chemical sediment. And so that's why people think the banded iron formations are a result of potentially precipitation with microorganisms involved, but in a volcanic environment. And in Western Australia, here's a diagram showing you in the geologic record with conventional time where these banded iron formations form. And the Hamersley Basin of Western Australia near the Pilbara is the world's largest repository of these banded iron formations and huge open cast iron ore mines, and supplying the world's steel mills. Of course, they're also in Canada, in South Africa, and other parts of the world. Minnesota, up near Duluth, you've got the Mesabi banded iron formations there. They're here in the US as well. But they're a rock that are unique. By the time you get to the flood up here, banded iron formations are no longer represented in the record. These are unique to the Precambrian. What happened during the creation week? So we've defined things, we've set out the problem. Now let's delve into the scriptures to see if we can figure out where these rocks fit and what would be the created rocks. The Genesis account doesn't mention every detail, so some details need to be inferred, though we always need to go back to the scriptures and their authority to check that we're inferring the right things. We may infer that on day one, when God created the earth, it was already rocky. You know, Kurt mentioned it might have started with Russ Humphrey's idea of a water ball, but we would argue that by the time at the end of the first day of creation, we would have essentially had or started to have the threefold structure inside the earth of the core mantle and a rudimentary crust, because on day two, it was covered by water. On day two, we may in fact have some early sediments and even microorganisms involved on the ocean floor. But by day three, we're told that God created the dry land, and then he created plants to put on it. By the way, when it tells us he put the plants on that dry land, it infers that there was a soil, and a good soil has microorganisms, so that means when God created that soil, he had all the microorganisms there necessary for healthy plant life. So we can infer that at least by the beginning of day 3, there must have been a rocky crust beneath those encircling waters, because it makes sense, therefore, that that crust may have been created on day 1. But, so from the rock record, we know that these foundational rocks of the Precambrian, these granite metamorphic complexes, these massives and the greenstone belts between them, the oldest cause of the continent. So these may have already been starting to form on day 1. Certainly by the beginning of day 3, they were in place. They were the foundation rocks that God had put in place by the beginning of day 3. And so here we see these. This may have been, we may see here exposed, even today, some of the rocks left over still in place from where they were at, but on day 3, but below the waters. Because what happened on day 3? God created dry land. The best way to do that was to simply raise some of that crust up above the waters so that you would breach the waters, and we could call this the Great Upheaval, where God on day 3 said, "Let there be dry land," and He gathered the waters into one place. There was uplift of some of this primordial crust of granites and some of these sedimentary rocks that He'd formed earlier, and they were now exposed at the earth above the waters. But when that happened, what happens when you raise material above the water surface? The water is going to drain off, and that draining water is going to erode. It's going to erode, and the waters are going to retreat or regress from that emerging land surface. And so later in day 3, we could have, as a consequence of the Great Upheaval, the Great Regression. And those sediments that are carried by that water as it sweeps off that emerging land surface is going to get dumped offshore. So we could expect that any basement rocks, crystalline basement rocks from day 1 or early day 3 would have been eroded off, and some sediments would be laid on top of them as a result of this Great Regression. And so if this scenario is correct, then what would we expect to find in the rock record? We'd expect to find an erosion surface where the regressing waters had eroded over the foundational granite and metamorphic rocks. And we'd expect to find sedimentary rock layers without fossils, as plants and animals had not yet been created. Might have microorganisms, because there may have been microorganisms around on the pre-flood, on the ocean floor underneath those global waters, deposited either on top of the erosion surface or flanking these metamorphic complexes. And so we find these foundational cores on the continents, and they're overlain by an erosion surface surrounded laterally and on top of these massive sequences of sedimentary and volcanic rocks. And we see this graphically in the Grand Canyon, in the inner gorge, below the Great Unconformity. So this is how we're going to now go back to the Grand Canyon. Here's that Great Unconformity, the erosion surface marking the beginning of the flood. And we go down here to these the Zoroaster, Vishnu, schist complexes. These are the foundational granites and metamorphics. And then we have this erosion surface here, which is called the greatest unconformity, eroding the granites and the metamorphics. And then sitting on top of that, we have these Precambrian sediments and volcanic rocks that may be part of that great regression sequence. And also, eventually leading up, the last of these might represent pre-flood era rocks. And Kurt will have something more to say about that later. So here in real life, we can see, again, these granites and metamorphics of the inner gorge. We can see this greatest unconformity where we have this erosion surface marking the day 3 regression, and these represent the uplift. We have the regression, and then we have the sedimentary layers deposited on top. And here we can see both the greatest unconformity, the Precambrian sediments here, and then the great unconformity with the flood layers subsequently. You can see why the Grand Canyon is a great place with the Bible in one hand and looking at the rocks in the other. And so they're just to remind you of that sequence, stepping through from foundational rocks, early day, maybe day one, but certainly by early day 3, the erosion as God raised the dry land, and sediments that were deposited as a result of that regression and up into the pre-flood era before the flood came and later on. And here again, just to show you these rocks, there's those Precambrian sedimentary layers that may represent part of that great regression on day 3 and moving up into the pre-flood era, and the great unconformity above that. Sorry, I skipped. The great unconformity above that. Here again, we can see the great unconformity of the flood. They actually eroded down to these core rocks, these Precambrian granites and metamorphics. Again, the same here. So what are our conclusions before I hand over to Steve? The crystalline foundation basement rocks, the granites and metamorphics, are the lowest exposed layers on the rock record on every continent today, are likely the initial rocks that God created, probably on day 1 of the creation week, but certainly by day 3. We can't be dogmatic on that, but we recognise they had to be in place by early day 3 to then be uplifted to make the dry land. And we cannot see any difference between these created granites and metamorphics. They look very similar to later rocks that form by natural processes, quote unquote. Is there really anything such as a natural processes? If God is intimately involved with his creation, the very fact that the sun rises because God ordains it. So it's really a supernatural event when the sun rises in that sense. God is intimately involved. So we have to be careful using these terms, natural processes versus supernatural. Invariably, these rocks were eroded before, these foundation rocks were eroded before the sedimentary rocks, not containing any megascopic animal fossils, were deposited on top of them and beside these granites and metamorphics. This resulted from the great upheaval of the foundation rocks on day 3 to make the dry land, and the great regression that deposited these sedimentary layers on top of that erosion surface from the emerging waters at the beginning of during day 3. And we find this sequence preserved in the Grand Canyon. That's why it's a great outdoor teaching exhibit. The Precambrian and the crystalline basement rocks in the Grand Canyon represented the created rocks, separated by the greatest unconformity or erosion surface from the overlying younger Precambrian sedimentary and volcanic rocks that represent the latter part of the creation week and into the pre-flood era. And this is quite an emotional spot for many people when we take them into this place where they can put one hand on created rocks and the other hand on the flood rocks. Thank you very much.